Good morning, friend. My name is Yogesh Kumar. I am here to simulate the fabrication of NMOS and the PMOS. We simulate in the Microwind software. So here, first of all, we introduce brief idea about the Microwind software. So this is the Microwind software. See, this is the 5 lambda. It indicates the scaling. This is the upper row. In this row there are various icons. So this is the gun, means we use this icon to delete any component. This is to the run the simulation. This DRC is to check the if there is any error present in the design. So first of all we make it as a 1 lambda. So just click on the zoom in view, zoom in. This becomes 1 lambda. Now we have to design the n-type MOSFET. So in n-type MOSFET we know the substrate is p-type and the active material is n plus diffusion. See, here is the n plus diffusion, so just we take n plus diffusion. By lambda rule we know that the minimum width of the n plus active material is 4 lambda and the length is 14 lambda. So this is the 4 lambda and length is 14 lambda. See, this is the 14 by 4 lambda. Now we have to create the contact for the drain and the source and the gate terminal. So to create the contact for the drain, source and gate terminal, we require n plus contacts. This is the n plus contact. The size of the contact is 4 by 4 lambda. So this is the drain and this is the source. Now we have to create the gate terminal. To create the gate terminal, we require polysilicon. So here is the polysilicon. Just we take polysilicon. We know the height of the polysilicon above the active material is 3 lambda and minimum width of the polysilicon is 2 lambda and separation between the contact and polysilicon is 2 lambda. Now we check, click on the DRC error. See, if we click on the DRC error, then it shows no error. If some error is present, then it shows error. For example, if see, if we delete this and we told you that the height of the polysilicon is 2 lambda and width is 1 lambda. But here we take height is 2 lambda and width is 1 lambda. And if we click on the DRC error, then it shows error. See, polysilicon width is less than 2 lambda. Okay, now so we have to correct this and just okay, where is it gone? Okay, height is 3 lambda and the width is 2 lambda. So this is the polysilicon. What is the height? 1 2 3 3 lambda and width is 2 lambda, right? Okay, now it becomes 1 2 3 1 2 3. Now we have to apply the signal at the gate terminal and the drain terminal, and we have to observe the output at the source terminal. So to apply the signal, just add clock 1 at the gate terminal and we name it as a VG. Just assign it one signal at the drain terminal and just assign it as a VD. Now observe output as a V out and just assign it. Now to run the program, just click on this. We have to adjust, see, we have to adjust the signal. So just click on this and just make it slower and make this as a faster. Now we have to run the program. We know the threshold voltage of the NMOS is greater than 0, right? So it means that if the signal at the gate terminal is high, then NMOS acts as a short circuit, and output at the source terminal is same as the signal at the drain terminal. If the signal at the gate terminal is low, then NMOS acts as an open circuit, and output at the source terminal is remains as it is previous state. So this is the drain signal at the drain terminal, this is the signal at the gate terminal, and this is the our output. In this period, listen, in this period gate terminal is low, so output is low. Now in this period gate terminal is high, but the signal at the drain terminal is low, so output remains low. Now in low, now in this period the gate terminal is high, and also signal at the gate terminal is high, so output remains high. And after that gate terminal becomes low, so output at the source terminal remains at it, and previous stage is high, so it remains high. After that, when the gate terminal is high and drain terminal is, okay, and drain terminal is low, output becomes low.